what I was saying that last time we introduced to the impulse signals. What was impulse signals? What was impulse signal? impulse सिग्नल जो थे discrete time domain में, continuous time domain में, it was defined like this. So it was denoted by delta t, and we defined it as equal to 0 for all the values of t when it is non-zero, not equal to 0, and it was undefined. Its value is undefined when t is equal to 0. Okay, this was impulse signal in continuous time domain, but it is such that its integration from minus infinity to plus infinity delta t dt, its area under the curve comes out to be defined value, and that is to be 1. So this kind of signal is called continuous time unit impulse signal. Continuous time unit impulse signal. Okay, and if we draw it, we could draw it by, this is time axis t, and it is drawn like this. So its value is undefined. यहाँ पे हम कुछ भी नहीं लिख सकते इसका amplitude, but arrow से we can show that its value is so high and width is so small. This arrow indicates its value is very high and width is very small at t equal to 0. Okay, this is what we call continuous time unit impulse signal. Okay, similarly we have defined unit impulse in discrete time domain. In discrete time domain इसको कैसे define किया था? It was delta t, delta n. इसमें इसकी value we defined to be like 1 and 0 when n is equal to 0 and when n is not equal to 0. इसमें इसकी value defined है discrete time domain में. n of course is set of integer, so its की value हमेशा 1 रहेगी. जब n की value 0 है, n 0 रहेगी. जब n की value कुछ भी नहीं, n की value other than 0 है, तब इसकी value 0 रहेगी. Okay, 1 2 3 4 5 and so on, -1 -2 -3 and so on. Okay, so this is what the unit impulse signal in discrete time. And if we wish to draw its shifted version means if it, suppose we wish to define suppose n minus 3. Okay, n minus 3. So it will be 1 when n is equal to 3 and 0 when n is not equal to 3, its value will be 0. So the shifted version will be like this. So 3 will come here like this, 3 will come here like this. Okay, so it means it will get shifted to 3. This is called impulse signal and this is called shifted impulse signal. Shifted impulse signal. Okay. Shifted impulse. Agree? This is your axon. Okay. Now, what I can write is axon can be, suppose x, what will be this? We can divide it into these kind of signals. This plus यहाँ पे 1, सपोज ये 0 है, ये 1 है, ओके, फिर ये 0 हो गया, फिर ये -1 हो गया, ये 2 पे 0 हो गया, -1 3 एंड सपोज ये 4 पे 1 हो गया, ओके। n की वैल्यू n और -1 साइड पे, कितना 1, -1 साइड पे -1, ठीक है। ये 1 पे 1 हो गया, 2 पे 0, 3 पे -1, 4 पे 1 और -1 पे -1, okay, like this. So it means that I can write this signal as 2 times of delta n, क्योंकि delta n is, what is delta n? Delta n is, its value is 1 when n is equal to 0 and 0 when its value is not equal to 0. So इसको 2 times delta n लिख सकते हैं. Second is, this is shifted version of delta and its value is 1 at n equal to 1. So we can write it to be delta n minus 1. Delta n minus 1. Similarly, this is 0 times delta n minus 2, क्योंकि इसका एम्पलीट्यूड 0 है, डेल्टा n माइनस 2 पे. इसका एम्पलीट्यूड कितना है? -1. कहाँ पे? डेल्टा n माइनस 3. n माइनस 3 पे इसकी वैल्यू -1 है, फिर इसकी वैल्यू 1 है. 1 डेल्टा n माइनस 4, और इसको हम लिख सकते हैं -1 टाइम्स डेल्टा n प्लस 1, क्योंकि ये लेफ्ट हैंड साइड पे है 0 पे. ओके, सो वी कैन डिवाइड xn into these kind of shifted, this is called shifted, these are called shifted impulse signal. These are called shifted impulse signal. Okay, these are called shifted impulse signal. These are shifted impulse signals. So what we can write is, we can write delta n to be the sum of all these signals. Delta n could be written as sum of these signals. Okay, क्योंकि इसको इससे प्लस करेंगे, इन सबको प्लस कर देंगे तो we will get a delta, we will get xn. So xn can be written as, left hand side, so we can write it as minus delta n plus 1, delta n plus 1, क्योंकि ये delta n plus 1 पे इसकी वैल्यू -1 है, फिर 2 delta n plus 1 times delta n plus -1, डेल्टा n माइनस 1, ये वाला 1 टाइम्स डेल्टा n माइनस 1 प्लस 0 टाइम्स डेल्टा n माइनस 2, तो इसको आप नहीं भी लिख सकते कि कुछ 0 है, फिर -1 डेल्टा n माइनस 3, n माइनस 3 ये वाला आ जाएगा, डेल्टा n माइनस 3 पे इसकी वैल्यू -1 है, प्लस डेल्टा n minus 4 like this. So we can write xn in terms of, it means we can write xn in terms of sum of shifted impulse signals, sum of shifted impulse signal. We can write xn as sum of shifted impulse signal. In the generalized form, we can write any xn, any discrete time signal like this. Any discrete time signal can be written like sum of shifted impulse signal like this. K changing minus infinity to plus infinity, minus infinity to plus infinity, xk delta shifted version of impulse signal. This is shifted version of impulse signal. Delta n minus k is shifted version of impulse signal. Xk is the value of n, x की value, and we can sum like this. So any signal, any discrete time signal, any discrete time signal can be written as sum of shifted impulse signal. Okay, any discrete time signal can be written as sum of shifted impulse signal like this. So if we take x1n like this, it could be drawn like this. Okay, and in terms of unit impulse signals, it could be expressed like this. So any signal can be expressed as sum of shifted impulse. This was the story for unit impulse discrete time signals like this. If we take it into continuous time signal, this result can be written in continuous time signal like this. xt, this means any signal can be expressed as, this summation will go to integration, and this k, let us take it as tau, because t resembles tau, minus infinity to plus infinity. Okay, x tau delta t minus tau delta t minus tau d tau. Okay, so this summation result in discrete time domain can be extended to continuous time domain, because discrete time domain में summation operation is equivalent to integration operation in the continuous time domain. And this k, dummy variable, let us represent it by tau, then it can be written like this. Okay, so it means that any signal, any continuous time signal can be expressed in terms of shifted, this is shifted impulse signal, both in discrete time domain as well as in continuous time domain. This is an identity, it can be proven also. In most of the books it is proven also. So you can take it as this is true. So any discrete time signal or continuous time signal can be expressed as sum of integration of shifted impulse signals. ओके